Hello everybody. Thanks a lot for joining this TMF webinar. I'd like to make a self-introduction before moving to presentation part. My name is Simon Yang from Shanghai, China. I am PCI Product Sales Manager for Greater China. I'm responsible for the development of sales of PCI membrane products in China. And in previous 10 years, I acted as a TMF application engineer responsible for technical support to customers who use TMF. So again, thanks a lot for being here. Now we're going to move on to the presentation. In this webinar, we will mainly introduce PCI TMF. The presentation will cover several parts. Firstly, we'll very briefly introduce PCI membrane. Then we'll move to TMF product introduction, where I'd like to talk about what is TMF and how TMF is made. Then we'll talk about the features and the corresponding advantage of TMF when applied in some suitable air fields. After that, I'll illustrate how few typical applications and following with some real project reference sharing. With a brief summary, we'll move to Q&A session where I'll be more than happy to answer your questions. If we are not able to answer your questions right here, right now, we'll keep in touch after the webinar. So we're happy to further discuss on TMF product and its application after the webinar. Look forward to co-working with you in the future. Now we're going to talk a little about PCI. As you can see from the graphic, PCI membrane has a very long history dating back to the late 60s. In more than 50 years, PCI membrane specialized in leading polymeric tubular membrane and other polymeric membrane geometries for various applications, such as food and beverage, water and wastewater treatment, pharmaceutical and chemical, textile and dye stuff, and pulp and paper. With our broad product portfolio, we select the most appropriate membrane type to suit each application, minimizing investment and running cost and maximizing our customers' benefits. Among the most notable owners of PCI are IDE Corporation and medicine industry. Medicine industry acquired PCI in 2017. So now PCI is the only membrane for separation unit in this huge group. Talking about PCI membrane product. PCI membrane is specializing in production of tubular membrane, starting from microfiltration, ultrafiltration, nanofiltration to reverse osmosis. These tubular membranes are widely applied in material separation and water wastewater treatment. And next to our traditional product, we also have wire wound and hollow fiber membranes. But today, the product we are going to introduce today is TMF, which is a type of atypical tubular membrane. To illustrate how different, let's begin with what is TMF. TMF is short for tubular membrane filter. Typically, TMF is a structural composite membrane module, features PVDF membrane anchored to PE sintered substrate tube. The filtering rate of TMF is microfiltration to ultrafiltration with the in-out operation mode. And like other tubular membranes, the very open channel needs high cross-flow operation to maintain turbulent flow to avoid solid sedimentation. Because TMF normally handles with extremely high solid level, such as 2 to 5% TSS by weight, TMF flux ranges from 200 to 600, depending on application and conditions. which is quite high compared with normal tubular membranes. But certainly, the application area is also different. TMF is typically applied for high TSS inorganic wastewater filtration rather than organic matter content wastewater filtration or material separation. And TMF can also be defined as a kind of chemically inert, robust, thick wall tubular membrane filter that are available for backward. So in next several slides, we'll talk about how TMF is made. The first step is to make a sintered substrate tube, just as shown in the sketch. Ultra high molecular weight polyethylene particles are bonded together by heating. The micrograph showed the micrograph showed interior structure of substrate tubes, where you can see a uniform or mini-directional pore structure. And this one is a finished substrate tube after sintering process, so on which PVDF membrane can be coated. So next step is membrane coating. The PVDF membrane, its material is 100 unalloyed PVDF, so offering optimal chemical resistance and a high level of robustness and with long service life. And it is worth mentioning that the PVDF membrane not just spread over the surface, but penetrates the whole PE substrate layer, which allows the membrane to be anchored to substrate tube, giving very strong binding force. And the third step would be make a tube bonder and to assemble TMF module. The tube bonder is inserted into PVC housing and sealed with both end plates on both sides. So this makes TMF module like this one. This is our finished product. Here's the TMF ordering guide. I put this slide right here just because I want to tell what TMF specs are available. We can start from the tube ID right here. 2 means half-inch tube. 3 means 1-inch tube. So the tube ID respectively is 12.7 millimeter and 25.4 millimeter ID. And regarding to pore size, we have 3 types. SO1. SO1 means 0.1 micron, and 005 means 0.05 micron, and 0.02 means 0.02 micron. Except some test module, all industrial modules are in 6 feet length, which is around 1.83 meters length. And there are 1, 15, 37, and 61 core modules for half-inch tube spec, and 1, 4, 5, 10, 13 for 1-inch tube spec. So basically that's all about what is TMF. So I'd like to talk about how TMF works in next following slides. Like other tubular membranes, in-out mode and cross-flow filtration is typical for TMF. The liquid is fed into membrane tube with 3 to 5 meter per second velocity. Clear liquid passes through membrane and substrate layer, form filtrate. On the other side, retentate goes out of tube and form concentrated stream. Here is a unique feature is that TMF is available for back parts or backwards. Just right here. Let me show you. Sorry. As you can see, Uh, in filtering process, the suspended solids and particles gradually adhere to the membrane layer to form a sludge cake. So after every around 10 to 60 minutes, need backwash. Which means filtered water is forced back from the filtered side to feed and retained side to do the backwash for losing of the sludge layer and to remove the sludge in the tube. That's how the backwash works. So after around 10 to 60 seconds backwash, very short time, the system will return to service mode, filtration mode. Either compressed air or backwash pump can act as a driving force to push filtrate back. In the former case, you'll save a backwash pump, but need a water column for storage filtrate. And particularly worth mentioning is that backwash wastewater is sent back to concentration tank, not like hollow fiber UF, so which means no wastewater drain during backwash. Sorry, next slide. And now we're moving to TMF features and advantage part. As a specially designed tubular membrane, TMF is not suitable for all applications, but because of some remarkable features in its suitable application area, TMF shows incomparable advantage compared to competing membrane and process technologies. So please find this table as a summary. In next several slides, each feature and corresponding advantage will be discussed separately. The first one is a very open channel with half-inch or 1-inch ID membrane tubes. This makes it possible for TMF to handle extremely high solids without prefiltration. Maximum TSS is 18% by weight, but typically ranges from 2 to 5% by weight, which means 20,000 to 50,000 ppm as suspended solids. So the big pictures. The pictures right here show several types of slurry that TMF operate with. This one is a diisol silicone slurry. This one from chemically enhanced lime softening slurry, and this one is a heavy metal nickel hydroxide slurry, and this one is again lime softening slurry. You can see the concentration is very high, but certainly initial TSS might not be so high that it will be accumulated and maintained during cycling concentration. The next one is anchored PVDF, which means no delamination, no depth filtration. Although only the very thin layer on inner surface for filtration reduction. For TMF, the PVDF membrane penetrates the entire substrate layer. This makes membrane anchored to substrate tube, giving very strong bonding force. It is not achievable on some similar product, which is so-called laminated tubular membrane filter. We had a side-by-side comparison showed that the laminated PVDF membrane tends to delaminate under high suspended solids and frequent backwash. The test solution was the ferric hydroxide. As you can see, there are delamination area here and there, and the color of the substrate tube, the cross section, also changed to brown, which means there was some depth filtration. But on the other hand, if you see the TMF, okay, you can see there's no delamination, and the cross section of the tube is still in white color, which means no depth filtration. So that's a difference. Oh, right here, the filtrate of laminated tubular membrane is also a little brown in color because maybe there's a little very tiny ferric hydroxide has been passing through. Another feature about TMF is a substrate tube with a thick wall and omnidirectional pores in cross section of the tube. This gives the some characteristics like following: high strength, self-supportive, and available for backwash or backpass. Allowing backwash is very important when handling very high TSS inorganic wastewater, industry wastewater. You can imagine membrane tubes will be choked with slurry in a short time if there is no periodic backwash. So by the way, the average wall thickness for half-inch tube is 3.65 millimeter, and it's 4.3 millimeter for 1-inch tube. So really thick wall. And another one is 100 unalloyed PVDF. TMF is actually chemically resistant as the membrane material is 100 unalloyed PVDF. And besides, all others are chemical inert materials. That's why TMF can handle challenging liquids from hydrofluoric acid to waste caustic soda solution filtration. And beyond that, another benefit of high chemical inertness is available for extremely strong CIP. We all know that membrane needs to be chemically cleaned to restore their permeability. The higher CIP chemical strength, the better flux recovery effect, and the lower possibility of irreversible flux declining. So here we can see what kind of chemical TMF can handle for CIP: 5 to 10% acid, 1 to 5% caustic soda, and even we can do the bleach oxidizer cleaning like bleach, 5 to 15%. It's very high. And this one is a little interesting. The rugged inner surface area under SEM. You can see the PE particles. PE particles form peaks which protect the PVDF membrane in valleys. This offers high abrasive resistance performance, makes TMF suitable for filtration for some liquid contains rigid and sharp particles. To give you an example, this SEM shows silicon particles from semiconductor backgrounding and die SAW processes. The particles are very tiny, rigid, and very sharp. It's really a challenge for hollow fiber UF or other membranes, but TMF can handle such type of particles because of high abrasion resistance. Okay, now we are moving to the next part where we'll talk about TMF applications. Firstly, we may want to know where TMF will be set in a whole wastewater treatment system and what its function. Here's the typical flow diagram. As you can see, wastewater is fed into reaction tanks, maybe one or maybe several in series. In reaction tanks, certain chemicals is added, air mixing or mechanical mixing is necessary, and the pH is maintained to a certain range for precipitation. So in this case, in this condition, the target ions form corresponding insoluble matters and then form the reacted water. The reacted water contains suspended solids. will overflow or being pumped into TMF concentration tank right here. So TMF circulation pump then transfer the liquid into TMF for filtration. Retained water stream will recycle between the TMF modules and concentration tank in a cross-flow filtration mode. And the filtered water is sent to a separate tank and then being discharged or reused directly or to some membrane desalination unit such as RO, or even to evaporation crystallizer. And that suspended solids will accumulate in this dynamic concentration process. So a set flow rate slurry discharge from concentration tank is needed to maintain certain SS level. And typically, a dehydrator or such as a filter press will handle this sludge, transfer it to sludge cake, and the squeezed water can be sent back. So that is the whole process. We all know that there are some other solid liquid separation filtration process can achieve the same mission. To explain why TMF process is better, please see several comparison table as following. Here is one that TMF versus traditional settling tank, when designed for discharge per standard proposed. TMF, of course, TMF feels its advantage. No solid carry out because there is a membrane barrier. Better performance under high temperature with good turbidity and a higher flux under higher temperature. And no polymer, no PM needed. And a quick on-off mode. And no need polishing filter because TMF filter this, the turbidity is low enough and no chemical overdosing. But mostly regarding to wastewater reclaim system, the advantage of TMF are more obvious. Look at this block flow. A typical wastewater reclaim system is a very long process. After precipitation stage, we'll need a flocculation tank to form flocks, then a settling tank for solid liquid separation for sludge sedimentation, and settling tank treated water is normally not clear enough, good enough for membrane desalination. So a hollow fiber UF is normally needed to get low turbidity water. However, the hollow fiber UF itself needs some protection. So a multimedia filter or other type of polythene filter needed to protect the hollow fiber UF. That makes a very long treatment process with even with several risky points. First, right here, sludge carrying out from settling tank will affect the whole reuse system. The second one, UF has falling and fiber breaking issues. And third one, UF and subsequent RO have serious falling problem due to polymer dosing. On the other hand, when TMF applied here, the reuse process can be greatly shortened because no need flocculation tank, no need settling tank, no need hollow fiber UF because TMF filtrate is good enough for subsequent RO for desalination. So no need hollow fiber UF, hence no need multimedia filter to protect UF. So in one word, TMF replace multiple stage separation filtration unit and pose no polymer risk to subsequent RO. So far, TMF has been successfully applied in many industry wastewater reclaim systems. It is becoming more and more popular for several reasons. One step from slurry to clear water suitable for RO. And two, no need for flocculent agent, which is PM. Three, smaller footprint, less construction time, and less civil work. Four, higher recovery rate. And five, no need chemical overdosing, which is also very important for reclaim system, because overdosing of chemicals brings extra burden to subsequent RO. Also means high chemical consumption and high sludge yield. That's what we call short process. Here's a list. We list several typical applications. You can see in this table. Initially, and still being widely applied, heavy metal wastewater from various industrial fields such as PCB, electronics, metalworks, auto industry, and wastewater is normally treated for discharge per standard, but in recent years, more and more treat and reuse systems have been built. And high hardness, high silica content, high TDS water from great industries could be coal mining, coal chemical, industry park effluent, industry park effluent or leached wastewater from power plants and many others. So in many cases, these waters are treated for reuse, for reduction, or even for ZLD. So far, this is the most widely used field of TMF process. And next one is silicon particles. Silicon particles contain wastewater from semiconductor, especially from backgrounding and die-saw or cutting processes. Where there are high-grade DI water or UPW contains only silicon particles. So mostly this water is treated for reuse. And the fluoride wastewater or waste liquid is treated for discharge or for reuse. And some other phosphate wastewater, titanium dioxide wastewater. So I will talk about these applications in brief in following slides. First one is the heavy metal wastewater. Various regulated heavy metals can be precipitated and then be separated with TMF, such as cadmium, copper, chrome, nickel, lead, zinc, arsenic, and others. Precipitants could be alkali or sometimes carbonate, sulfide. Sometimes some coagulant is needed. So with pH controlling and mixing, insoluble metals form and then be sent to TMF for filtration. Treated water can be discharged or reused with subsequent RO. Here's what can TMF achieve. Because of a membrane barrier, TMF treated water is always better than effluent of settling tank. This is the flow diagram shows how TMF applied in heavy metal wastewater treatment system. In fact, the process is quite similar for other types of wastewater treatment. Often the difference is just a chemical precipitation reaction mechanism. And TMF application for high hardness, high silica wastewater water reclaim. So regarding to hardness, high silica, and other scaling ions removal for high TDS water reclaim, the water source could be quite different from RO reject water, cooling tower blowdown, FGD wastewater, industry park wastewater, and coal mine wastewater, coal chemical process water, and others, and also leached wastewater. So the common challenge is that too high hardness or silica concentration and other scaling ions cause serious scaling risk or a low recovery rate for subsequent RO. So with some precipitant dosing, such as lime, caustic soda, soda ash, and magnesium salt, and a special type NaAlO2 for silica remover. So all of these scaling ions forms insoluble type, and then separated by TMF. So TMF can generate low turbidity, low hardness, low silica water for subsequent RO to do the desalination with a much higher recovery rate. This is a typical block flow to show a high TDS, high hardness, high silica water reclaim system. So still need to remember that if no TMF, we'll have to set flux tank, clarifier, multimedia filter, OV filter, and hollow fiber UF to protect subsequent RO. So which is so-called traditional long treatment process. And next one is semiconductor industry backgrounding and cutting or dissolve wastewater. This type of water contains only very fine silicon particles, and the mainly in ultra pure water or at least the DI water. So which means the recovery rate, recovery value of water is very high if particles can be removed. But there is challenge. Hollow fiber UF is not feasible due to hard and sharp particles character. And settling tank can help neither because the tiny silicon particles tend to suspend in water instead of sedimentation. So as a unique total solution, TMF can be chosen as the key filtration process. So the special membrane structure and properties make it possible to get outstanding filtrate quality in a greatly simplified treatment process. As a matter of fact, titanium dioxide wastewater has similar characteristics: high solid, high recovery value, and traditional process is not feasible. So in this case, open-channeled backwash vapor TMF is the preferred separation process right here for titanium dioxide filtration. The process is simpler. Normally, there's no chemical precipitation stage. However, to enhance TMF performance, according to our experience, sometimes a liter PCI, which is polyaluminum chloride, need to be dosed before TMF separation. And fluoride wastewater treat and reuse, also similar to other, except with a different reaction mechanism. For fluoride, the precipitants are normally lime, calcium chloride, and PCI. And this is a flow diagram for fluoride wastewater treat and reuse system, just for your reference, because different engineering company will design their chemical reaction stage based on their own experience. And some other applications, for example, phosphate, wastewater treat and reuse, and some waste acid recovery. So now we'd like to share some TMF reference with real system pictures. The first slide shows heavy metal wastewater treat and reuse systems. This real system relates a different type of heavy metal wastewater treatment and reuse, where you'll find TMF handler, copper, nickel, chrome, and other heavy metals wastewater came from PCB, electronics, steelwork, photoelectric. The wastewater flow rate ranged from several cubic meters per hour to several hundred cubic meters per hour, and most of them are treated and reuse systems. But also, some systems were built for discharge per standard. Next is a high hardness, high silica water reclaim system. Almost all TMF enhanced systems were designed for water reuse, reduction, and even for the LD purpose. In recent years, more and more coal mine wastewater ZLD systems have been built due to increasingly strict state policies. And the same is true for the coal chemical industry. And another booming industry is coking industry. And we didn't put picture here, but please remember that there are hundreds of TMF enhanced chemical softening systems are serving in legit ZLD plants in waste incineration power plants in China right now. And this slide shows TMF reference for silicon particles content wastewater, treat and reuse, related to semiconductor, microelectronics, and magnetic. The top left picture is a 150 cubic meter system located in Korea. Other systems located in China. And here are reference for some other interesting application. This one is zirconia and acid separation. This one, and the hydrofluoric acid reuse. Fluoride